This video is for Section 7.2, Sample Proportions. So if you're dealing with a sampling distribution of a sample proportion, you're going to choose a simple random sample of size n from a population of size n with proportion p of successes. Let p hat be the sample proportion of successes. Then the mean of the sampling proportion of p hat is the mu of p hat, which is just equal to p. P would be, again, the proportion of successes. The standard deviation of the sampling distribution of p hat is the standard deviation of p hat, which is equal to the square root of p times 1 minus p over n, as long as the 10% condition is satisfied. And just a reminder, this 10% condition is that the sample that you choose has to be less than or equal to a tenth of the entire population. Also, as n increases, the sampling distribution of p hat becomes approximately normal. Before you perform normal calculations, check that normal condition is satisfied, and so that just means that you do the sample size times the probability that it occurs, and it has to be greater than or equal to 10, and the sample size times 1 minus the probability of a success, which has to be also greater than or equal to 10. So check your understanding. About 75% of young adult internet users ages 18 to 29 watch online video. Suppose that a sample survey contacts a simple random sample of 1,000 young internet users and calculates the proportion p hat in this sample who watch online video. So the first thing we have to do is find the mean of the sampling distribution of p hat, and we have to explain that. So if we're finding the mean of the sampling distribution, it's important to note that in this case the sampling distribution and the population distribution are going to be the same thing, or the population proportion are going to be the same thing. And so because that is true, we can say that the mean of p hat is going to be equal to p, which is 0.75. And so remember that p is the probability of the success, and so that would be 75%. 2 says find the standard deviation of the sampling distribution of p hat and check that the 10% condition is met. And so for this one, we are going to use the formula that was on the last page. So the standard deviation of p hat equals the square root of p times 1 minus p over n. And so our p, of course, is 0.75. And our n is the sample size, which in this case is going to be 1,000. We know that 1 minus 0.25 is going to, or 0.75 is going to be 0.25, so we can simplify that a little bit. And so when we go to the calculator, eventually we can do second x squared to get the square root, do alpha y equals to get the fraction. On top we would say 0.75 times 0.25, and on the bottom of our fraction we would say 1,000. And that gives you 0.013693069. And so approximately 0.0137. The other thing that we have to answer for this question is we have to check that the 10% condition is met. So what that means is that basically our sample that we choose has to be 10% of our entire population. And so if you think about, our sample is 1,000, so that would mean that our entire population would have to be only 10,000. And if we're talking about people that are internet users between ages 18 to 29, that's definitely going to be more than 10,000. So that means that our 10% condition is definitely met. On number 3, it says, is the sampling distribution of p hat approximately normal? Check that the normal condition is met. All right, so the way that we would do that is we would have to check and make sure that NP had to be greater than or equal to 10, and we also need to check that N times 1 minus P is greater than or equal to 10. So our N is our sample, which is 1,000. Our P is probability of a success, which is 0.75. And so 1,000 times 0.75 is going to give us 750. 750, of course, is definitely equal or greater than or equal to 10, so that's good. All right, when I do this one over here, I'm going to have 1,000 times 1 minus 0.75 has to be greater than or equal to 10. And so that would be 1,000 times 0.25. And so essentially, we are taking a fourth of 1,000, which gives us 250, and 250 is definitely greater than or equal to 10. So that's good. All right, because both of those conditions were met, then that means that our sampling distribution of p hat is approximately normal. 4 says if the sample size were 9,000 rather than 1,000, would this change the sampling distribution of p hat? All right, so we would say 9,000 times 0.75 greater than or equal to 10. That's definitely going to work. And 1,000 times 1, actually 9,000 times 1 minus 0.75 is greater than or equal to 10. And that's definitely going to work, which means that it would be approximately normal. And because it's approximately normal, that would mean that the mean of p hat would be equal to the probability of a success, which in this case would be 0.75. When we go to calculate the standard deviation, however, we would say the square root of 0.75 times 1 minus 0.75, and we would divide this time by 9,000. Whenever you do that, you're saying 0.75 times 0.25 divided by 9,000, and whenever you do that, you could work that on the calculator to get 0.0046. So we can see that the mean would stay the same. It would be approximately normal still, but the standard deviation would change by quite a bit. All right, so another example using a normal approximation for p hat. So a polling organization asked a simple random sample of 1,500 first-year college students how far away their home is. Suppose that 35% of all first-year students actually attend college within 50 miles of home. What is the probability that the random sample of 1,500 students will give a result within 2 percentage points of this true value? Follow the 4-step process. All right, so the first thing we're going to do for the 4-step process is to state. So we're going to state what is our question, or basically what they're trying to get us to find. So we want to find the probability that p hat falls between 0.33 and 0.37. And the reason we want it to be 0.33 and 0.37 is because we want to be within 2 percentage points or 0.02 of 0.35. So 0.33 obviously is 0.02 below that. 0.37 is obviously 0.02 above that. Basically, what that means is in symbols, that's the probability that p hat is greater than or equal to 0.33, but less than or equal to 0.37. The next thing we need to do is discuss the plan. So for the plan, we know that we're taking an SRS of 1,500 first-year college students. So we know we have an SRS of size n equals 1,500 drawn from a population in which the proportion P equals 0.35. And that is people that attend college within 50 miles of home. What do we know about the sampling distribution of p hat? All right, so things that we can tell about the sampling distribution of p hat. For one, its mean is going to be equal to 0.35. The second thing we could do is we could check the 10% condition. And so what that means is we want to make sure that if we did 10 times the 1,500, that we would get 15,000. So we do, so we're good. And because we know that there are over 7.1 million first-year college students, then we can find the standard deviation for p prime, or p hat, to be the square root of p times 1 minus p over n. And so that would be 0.35 times 1 minus 0.35 over 1,500. And so whenever you work that out, you would get 0.0123. The next thing we should think about is, can we use a normal distribution to approximate the sampling distribution of p hat? So in order to do that, we would need to check the normal condition. And so that would be n times p, which of course would be 1,500 times 0.35, and that gives us 525. which just has to be greater than or equal to 10. So we're good with that. All right, the next thing that we would need to do is check n times 1 minus p. And so when we do that, we would get 1,500 times 1 minus 0.35, which is really going to be 1,500 times 0.65. And whenever we do that, we get 975. And 975 must be greater than or equal to 10 in order for us to use the normal approximation. So because both of those worked out, the normal approximation will be quite accurate. And so then we need to think about, what do you do? All right, so because we know it's going to be approximately normal, we could standardize or find the z-scores for p hat when p hat is equal to 0.33 and when p hat is equal to 0.37. So we are going to standardize. And so for p hat equal to 0.33, to find the z-score that goes along with that, we would say 0.33 minus the mean over 0.0123, which was the standard deviation that we got up here. So whenever we do that, we would get negative 1.63. We're also going to do for p hat when it's equal to 0.37. So we're going to say z equals 0.37 minus 0.35 over 0.0123. Whenever we do that, we get 1.63. So if we're thinking about this, we would have our normal curve. I don't know what happened there. It was beautiful. Oh. All right. So we are going to find the area that is between here and here. So when z is equal to negative 1.63 and when z is equal to 1.63. And once we do that, that's going to give us the probability that p hat is greater than or equal to 0.33 but less than or equal to 0.37. And so we're going to be finding the probability that the z is going to be less than or equal to 1.6, greater than or equal to negative 1.63, but less than or equal to 1.63. So we could go on the standard normal table. You would really think at this point I would have one like saved, you know, but no, I don't. So we want to find negative 6.3. So negative 1.6 and then go over to the 3. That's not a really good one. Let me find a better one. Is this the one? I think this is the one that you guys would have. Just kidding. Nope, not that one. All right, so we're going to find 1.63, which is 0.9484. So we're going to have 0.9484, and we're going to subtract out. So obviously these are the positives. You need to look for the negatives, which was, I think, this one. Yep. So negative 1.63 is over here, so 0.0516. 0.0516. And so whenever you work that out, you would get 0.8968, which means that our conclude would show that about 90% of all simple random samples of size 1500 will give a result. That was a mess. Within 2 percentage points of the truth about the population. All right, without having to use the z-score and the standard normal table, you could have also done this problem on the calculator. Of course, because it's normal, we could use normal CDF. And your lower bound would be the 0.33. Your upper bound would be the 0.37. Your mean is the 0.35, and your standard deviation is the 0.0123. Whenever you do that on the calculator, you would get approximately 0.89605, which of course is going to give you about 0.90 or 90%. So either way, you can get the right answer. I know that most of you probably prefer to use the calculator, so feel free to use that, although I do want you to be familiar with the standard normal table and how you use that.